Welcome to lesson 1 of 2 in this tutorial, covering the density of materials. This is the first lesson in our series of 2 videos on the topic of changes of state. Here are the key learning objectives for this section. The first is to calculate density. The next is to look at the particle model, and finally we will investigate densities. Here are the AQA specification points for today's lesson. Feel free to pause the video now and have a quick read through them before we begin. The first specification point will cover the equation for density. Density is a measure of how heavy an object is for its volume. In other words, it's a measure of how compact a substance is. We can define it using this equation, mass divided by volume. Here's the short version you can use in AQA exams. Density is represented by the symbol ρ. The units should be pretty familiar to you, as we've seen them in another tutorial. Remember, the units for density in this equation are kilograms per meters cubed. The most common units for density are grams per centimetres cubed, followed by kilograms per meters cubed. A density of 1 gram per metre cubed means that 1 metre cubed of the substance will weigh 1 gram. Let's attempt this practice question to apply the equation we've just learnt. We'll go through it together step by step. First, we need to write out the equation for density, which is mass divided by volume. In this question, we have been given the mass in grams, but to use the equation, we need a mass in kilograms. Similarly, we have been given the volume in centimetres cubed, so we need to convert into meters cubed. So here, we would say that 4,500 grams is going to be equal to 4.5 kilograms. Also, 146 centimetres cubed is going to be equal to 0.000146 meters cubed. Now that we have a mass in kilograms, we can use the equation. We need to remember to give our answer to 1 decimal place and state the correct units. So here we would say density is equal to 4.5 divided by 0.000146, giving us an answer of 30821.917. Now we'll give our answer to 1 decimal place, so we'll say 30821.9 kilograms per meters cubed. Now let's look at the particle model. Particles are the fundamental units which will make up all substances. There are 3 different states of substances: solids, liquids, and gases. The arrangements and energies of particle will affect the density of each state of matter. Exam questions may just give you a diagram of particles from which you will be asked to work out the state, solid, liquid, or gas. Next, we will cover the differences in density between different states of matter. This figure shows the 3 states of matter: solid, liquid, and gas. Here, we can see that the particles are in fixed positions in the solid, whilst those in liquids and gases are not. In solids, particles can vibrate, but in liquids they can move over each other. The particles within a gas can move freely. The particles in a solid have a much higher density than those in a liquid and those in a gas. Solids and liquids are incompressible, whilst gases are compressible. The amount of kinetic energy will increase as we go from a solid to a liquid to a gas. Finally, when these are placed into a container, solids will not take the shape of the container, whilst liquids and gases will take the shape. Here's a table showing the 3 states of matter. Let's fill in the details. We'll start off by looking at the particle arrangement in a solid. These are in fixed positions. The particle energy in a solid is very low, and the forces of attraction between particles, however, is strong. The particle movement is that they vibrate around fixed positions. Their density is very high. Now we'll look at a liquid. Here, the particles are closer together. They have a medium energy, and the forces between the particles are weaker. The particles are able to move past each other randomly. This makes the density less than solids, but more than a gas. Finally, we'll look at gases. Here, the particles are far apart. They have the highest energy. However, they have the weakest forces of attraction. They move very randomly, but also at high speeds. And their density is very low. Now, we will look at drawing simple diagrams to model the different states. For AQA exams, you will be expected to recognise and draw the diagrams shown here. You may be asked to compare the different states of matter in an exam. To do this, you should consider all the information we've just mentioned in the table, especially the arrangement and movement of particles. Our final specification point is to cover one of the required practical activities for this section. For AQA exams, we need to be able to work out the density of solid objects and also those for liquids. We will come across 2 different kinds of solids. These are regular and irregular. Let's look at the method for investigating the density of a regular solid. First, we need to gather all the equipment. Next, we will measure the mass of the object in grams. To measure the volume of a regular solid, you can use measurements and the appropriate formula. For example, if you want to find the volume of a cube, you would use the formula width times length times height. You should record this in centimetres cubed. Now we can calculate the density using the formula density is equal to mass times volume. Previously, we measured our mass in grams, which was to maintain accuracy. However, for the formula, we need our mass in kilograms. Again, we recorded the volume in centimetres cubed for accuracy, so we need to convert it into metres cubed. Here's a summary of all the steps we've just been through. Now let's look at the method for an irregular solid. Again, our first step is to gather all the equipment. Like the last experiment, we will record the mass of the object in grams. To measure the volume of an irregular solid, we will use displacement. Here, we will place the solid into a beaker of water and then increase the water volume until it shows the volume of solid. We're going to show this a little later in the video. We can now calculate the density using the formula mass times volume. Here's a summary of the steps for this experiment. You may be asked to write out the experiment to find the density of any kind of solid. Make a careful note of whether the solid is regular or irregular, as this will affect how you measure the volume. Let's look at the different ways to find mass and volume. We can find the mass by weighing and the volume by displacement, as we described earlier. Now let's look at the method for liquids. As always, our first step is to gather all the equipment. For this experiment, we need a liquid, a measuring cylinder, and a top pan balance. To measure the mass of the liquid on its own, we'll have to subtract the mass of the beaker. To measure the volume of the liquid, we simply use a measuring cylinder. Now that we have our values, we can calculate the density of the liquid. For liquids, we need to be particularly careful about how we measure the masses. We must remember to subtract the weight of the measuring cylinder, or else we will get inaccurate results for the density. Here's a summary of the experiment to measure the density of a liquid. Let's try this practice question now. We'll go through it together in the next few slides. First, we need to find the volumes of each of the items. These are shown here. We need to remember to subtract 15 grams for our equation, since this is the weight of the beaker. Now, we can work out the volumes of each item. We can do this using a series of equations. This leaves us with the values of P equals 17, J equals 4, and K equals 7. Now, we can use our formula to find the densities of each object. This is simply mass divided by volume. This question was quite difficult since it used algebra. If you're comfortable with simultaneous equations from maths, then the calculation may be a bit easier for you. We've now covered all the learning objectives for today's tutorial. Feel free to pause the video now and re-watch anything you are unsure about. We've now completed Lesson 1,